Hello, everyone. Welcome to day 18 of MCR 4. So we are in the finance unit, and we're going to start by evaluating some more algebraic expressions, looking at how to do that on the calculator, and then putting those into a couple word problems for today. And then you do have a day 18 assignment that you'll want to do and turn in. So welcome. Hope you're all doing well. So to start, we have several practice problems here. And the idea is if we have the information, can we put it in the formula? Can we figure out how it goes in the calculator correctly? So I'm going to get my pen going here. So we have this formula. Again, we go order of operations. We go PEMDAS. So we go inner parentheses, then exponents, working your way out. Everything in the top gets done before everything on the bottom. Think of those as two separate sets of parentheses. And what we're going to first do is plug in all the numbers, but looking at how we're going to do this, we're going to do the inside parentheses. Then we're going to do the next set of parentheses. And you do order of operations within them too. So we'll do the exponent before the subtraction. Then we do the next set of outer parentheses. And that's when we'll do these two and divide them. So that's the idea of the order we're going to go in. And again, I'm going to show you calculator and plugging in. All right, so when I put in the numbers, I'm going to write it exactly how it's written with parentheses. First parenthesis D, second parenthesis 1 minus parenthesis 1 plus, and then it says R over K to the negative K, close, close, and again, close, close. And now I'm on to the green down here, which is R over K. So how this is going to look in the calculator, you can type it as you see it. You just need to put all the parentheses there. Or I like to go the inside first, then raise it to the power, etc. So it's completely up to you how you want to do this. But in the calculator, you can do it by doing parentheses, exactly as you see, 450, parenthesis, exactly as you see it, 1 minus, 1 plus, and then you don't need parentheses here because they aren't in the original either. The calculator will know to go in that order. And then right here, you put caret. I would put an extra set of parentheses at the negative 12. Then close, close, divided by 0.05 divided by 12. And that should get you your answer. So right here, because of the negative, I like to put another set. So what we've done is added parentheses here, and then we put all that in, and then we just went right in order. If you don't like that, then type this in and click enter. Then raise it to the negative 12 power with the parentheses around negative 12, click enter. Then do the 1 minus that answer, don't round at any point, click enter. Then you would multiply it by the 450, click enter, and then divide by those in parentheses. So how you go about doing it is really up to you. If you want to go piece by piece, that's fine. If you want to throw it all in at one time, that's fine too. What you should end up with is 5,256 and 55. And it says round to the nearest 100. So make sure you're pausing a minute and really making sure that you're getting that answer out of your calculator. All right, now we're going to go on to question 2. Changing up the colors so it looks interesting. Similar idea here, we've got dr, but this time we've added in just a little more on the exponent. Right here at the negative n times k, I would again put another set of parentheses there, and I would add it into the formula as I'm going. So when I try to type this, I see that it's going to be another formula, another set of parentheses. So I'm going to write this exactly as I see it. 1200, I'm putting all the parentheses in, R, whoops, that was a 2, K. And right here, I'm going to put it in as negative 20 times K, or you could put it in as negative 80. And there was a 1, 2, and then all of that divided by R divided by K. All right, so how this would look in the calculator is parenthesis, 1200. Then you could do parenthesis 1 minus 1 plus 0.027 divided by 4. And then caret, negative 20 times 4. Okay, we added those in, so then there's still 1, 2 to go. Divided by 0.027 divided by 4. I would again make sure you're going through and doing these and getting them right here, so that way you have time if they're incorrect. And you get something to the effect of about 74,000. Make sure you're rounding correctly. These did tell us to round to the hundreds. So again, if that's not working for you to put all of that in at once, then try this method. Go to the innermost parentheses and type this in, then click enter. Then raise it to the negative 20 times 4, but put it in parentheses. And by raise, I mean this caret button. Then hit enter. Then don't round anything. Type in 1 minus that whole piece. Click enter. Then you would multiply it by the 1200. Click enter. Oh, that was not a good choice for that. Then divide it by parentheses, the 0.027 divided by 4. And I'll put that parenthesis back. And then again, make sure you're taking some time to go through these to make sure you understand the calculator. That way, when you get to the actual problems, you'll be okay. All right, continuing down. Now we're gonna add in an equals. So it's solve for PO when D is 45,000, 0.07, 1, and 15. So again, I would add in my parentheses right here, knowing that I now have that extra set, and then put in the information we have. So it says PO is equal to, and then let's see what it is, parentheses D, parentheses 1 minus, parentheses 1 plus, R, K. And then again, I'm going to raise it to the negative in parentheses n times K, close, close. So making sure all my parentheses match. All divided by 0.07 divided by 1. So in the calculator, what that's going to look like is same way it's looking there. Parentheses 45,000, parentheses 1 minus, 1 plus, 0.07 divided by 1. So I'm right here. Then I'm going to caret it, negative 15 times 1, close, close, divided by 0.07 divided by 1. Right, so take a minute. Are you really getting that answer? Are you putting in the negative? Also, make sure you type the negative key. Don't type the minus key. If you're getting an error, a syntax error, watch to make sure you're typing the right symbol there. So you come up with 409,856,13 as a final answer. So if you have that, you are in good shape. If you have a syntax error, click go to and see what you typed in wrong. That's what I like to do versus guessing. And again, make sure that negative button is a negative, not a minus, and make sure you're putting in the right number of parentheses. And if you're not a big fan of trying to do it all at once, again, work inside out. And you can always do this as many steps as you need. No problem with that. Okay, so now would be, okay, so I'm going on to question 4. This one looks a little different. It says solve for D. And that's a very common question to need to solve for the deposit, the monthly deposit when we're talking about finance. So I want you to rethink of this question like this. PO equals, and then we have D here. But because multiplication and division are commutative, you can pull this piece out because the math will work the same. So I'm kind of going to pull that piece out and now write those parentheses. And kind of write it like that. And why I'm going to do that is I want to solve for D. So once I get this number in here, I'm going to divide it over into the PO. And I'm not going to try to do that all at once for a moment, but I can rewrite this D outside. So I took away these outer parentheses and rewrote it so that way I can divide it over. So now it's similar to PO equals D times just some item, where when you divide by that some item, you're going to get D. X just happens to be a little more complex. So in question 4, it's PO equals, and then I'm going to leave the D out. So 1, remember I put big parentheses here. So I added those in, 1 minus 1 plus R K. And I'm also going to put in parentheses here to the negative NK, close, close. Oops, sorry, that is only one set of close. Yep, because it's 1, 2, 3, 4. Yep, the outer one's already there. And then divided by 0.06 divided by 12, close again. Okay, so how I would kind of work this one is I would definitely do inside out on here. I would take this piece and go ahead and get your answer. And then I would raise that to this piece, then subtract it from 1, divide it by 0.06 divided by 12, then divide that number in. All right, so what you have if you're doing this correctly, and if you're not, just go back and try it again. This whole piece, do it separately. So get this one number, and you can do it if you want to do it all at once. Just have all the parentheses there. Don't worry about the outer parentheses. And what you should get if you're doing that right, and if you're not there yet, pause me and see what you get. You should get 300,000 equals D, and this whole piece should turn into 139.58077717. I wrote every single decimal there for a reason. Don't round it till the end. Then you're going to divide. So you're going to take 300,000 and divide it by that entire piece. And that's going to give you your D. So again, if this is too quick, pause. But you should get 2,149.29. Okay, and again, pause me if you need to. Work through the problems, make sure you're getting them. All right, so that brings us into what we've actually been working on, which are payout annuities. So we know an annuity is something that you put money in over time or you withdraw money from over time. So that's what a payout annuity is. They're typically used, after retirement or on a fund note if you have a lottery lump sum that you want to take out over time. So with the retirement idea, you might take out money each month to live on. You want the money to last a certain number of years. So you want to figure out how much you can regularly withdraw or how much you needed to save up. So we have a couple of variables here. Your PO is the balance at the beginning. So that's that starting amount, starting principal. So that's the amount you've saved for retirement. Or in my example, I like to think that's how much we won in the lottery. And we have to put in this payout annuity. D is the regular withdrawals you're going to take out. Now, D can be years, it can be months, it could be weeks. You just figure out what it's going to be. R is that annual rate that you're going to get in decimal form, as always. So the 6%, 2%, whatnot. K is the compounding periods in a year, and ends the number of years that you're going to take those withdrawals. Excuse me. So again, this is a great formula to figure out, how much do I need to get a certain amount every week or year, so forth. So how you have a payout annuity is that you're taking out regular withdrawals. That's the key. I have a payout annuity if I'm taking out regular withdrawals. And the benefit to a payout annuity is you might not need all your money at once. So the money you're not taking out is still earning interest. So it's a savings annuity, but paying you out. So keep that formula up top in your notes. You don't have to memorize these. You get the formula sheet when you go to take your 154 test. So you want to be able to withdraw $25,000 each year for 15 years. This is maybe a retirement account. You think that that's going to really help bolster where you want to be. You find an account that earns you 8% interest. How much do you need at the beginning? So this is specifically asking you for PO. How much do I need in that account? How much do I need to have saved? So for the formula, we've got the PO equals D 1 minus 1 plus, and you just worked with these formulas when we were looking at how to work the calculator. So hopefully that'll make it a little bit easier to type these in. And now we're going to plug in everything we have. So our D value from here, let's actually put in what these are over here. So we've got some information. D is that we want to withdraw $25,000 a year. N is 15 for 15 years. R is 0.08. And then if we look at the other information, each year, so that's going to be also our compounding number. It's going to be one time per year. And then that should be all the information we need. Okay, so we're solving for PO. So it's 25,000, 1 minus 1 plus R over K. Remember, I put an extra set of parentheses here, to the negative NK, close, and then all divided by 0.08 divided by 1. So how you can type that in is parenthesis 25,000. Here's our calculator part. 1 minus 1 plus 0.08 divided by 1. Caret symbol, negative 15 times 1. Close, 1, 2, 3. 1, 2, 3. And then divided by the 0.08 divided by 1. And that'll tell you that the amount you need is 213,986.97. And it gives you that information. So if you have an account that you've managed to save up to that amount, or that's the lump sum, what have you, that account will be able to pay you out $25,000 each year for 15 years. All right, then another type of question. This time you save $450,000 for retirement, get a nice account. How much can you take each month, knowing that you want to take withdrawals for 25 years? So that gives us the PO. So this is working the other way. We've saved up. How much are we allowed to take so that this money doesn't run out before we want it to? And since it's monthly, K is going to be 12. So this goes back up earlier to where we took the D out of the formula and solved for the rest of it and then divided it in. So if we do that, it's 450,000 equals, and then D came out. And then we put the rest of it, so 1 minus 1 plus R, K, to the N, K, divided by R, K, close. So now I've got these So I've got open, 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 close, close, but this is one piece. And then once I have that number, I can divide it over. So calculate this piece first. So as you're doing that, take this piece, hit enter, then raise it to the negative 25 times 12, hit enter. Then we're going to do the 1 minus piece and then divide it by this piece. Once you have that number, again, pause me anytime if you're thinking I can't type that fast. Once you have that number, you should get 450,000 equals D, and all of that should turn into 158,9556228. Don't round it. Divide it over, so 450,000 divided by that, and you find that every month you can take a nice hefty 28.30 and 98 cents. So again, make sure that you are trying these problems. Make sure you are getting the answers correctly. And then at this point, there are 3 more practice problems with the word problems. If you're feeling pretty confident, this would be a good spot to pause the video and try all of these. If not, at any point, pause when you have a minute. Okay, so for question 7, we want to withdraw $50,000 a year for 15 years, found a nice account earning 10% interest. How much do we need at the beginning? So how I know this is a payout annuity, I want to do regular withdrawals for 15 years. So A is asking me for a PO. Then we'll come back to the rest of this. Okay, so I've got D is 50,000. Those are my regular withdrawals. N is 15 years. Since I'm taking them out yearly, K is 1 and R is 0.10. Just watch your decimal there because it's a nice 10%. So this is a straightforward, let's solve for PO. So have the formulas out just so you have an idea where these are coming from. This is D. And then it says 1 minus 1 plus R over K raised to the negative NK. And then it's all divided by that R divided by K. So you can type it in exactly as you see it there with the caret, with all of that. So pause, make sure you have that. What I come up with is $380,303.98. No small feat, right? Here's the good part though. You want to withdraw $50,000 for 15 years. And you find that that's what you need. But let's take a look at part B. How much total did you get out of this account? Well, you took out $50,000 every year for 15 years. So you actually took out $750,000. So how to get how much you take out is D times N times K. It's just K in this point was a year. So you took out $50,000 for 15 years. Multiply those together, you took out $750,000. It's a lot more than what was in the account. So by leaving it in that savings annuity, how much is interest? Well, you got $750,000 and you had only paid into the account that much. So by leaving the money in the account, as you're taking out the money you need, you get a good amount of interest as you go. So that's kind of the benefit to a savings annuity. Instead of taking it out as a lump sum, if you don't need it all at once, you can be getting interest on the money you're not using in the meantime. So again, I mentioned it might be good to pause and try these problems on your own and then go over with the video. So you can afford a $900 per month mortgage payment. You have a 30-year loan at 7.3% interest. and it's per month. So that's also my K. All right, so now this one says, how big of a loan can you afford? This is very similar, and in fact, it uses the exact same formula as payout annuities, but now the PO is your loan amount and D is your payments. Same formula, same idea. We're depleting an amount, but this time you have to pay it, so it's not as fun. So same formula, like I said, how big of a loan can you afford is PO? So we're asking, what is that total amount that you can have? So it's going to be 900, 1 minus 1 plus 0.073 divided by 12 to the negative 30 times 12, sorry. Those are my parentheses for that piece, and then 0.073 divided by 12. All right, so go through that formula the exact same way we've been doing it. Either type it in with the correct parentheses or go inside out. It's up to you how you want to do it. I'm highlighting the order that I would recommend. Then you do that whole piece, then you multiply it by 900, and then you divide. So hopefully the calculator part is going okay for you, because that PO, when you calculate it out, should be 131,277.4452, which rounding is 0.45. So the answer to that first question looks like that. So that's for this house, for this mortgage payment, that's how big of a loan you can afford to take. Here's where it gets interesting. Just like before, it was really great that we got all that interest on a payout. If it's a loan, mortgage, car payment, it goes the other way. Now it's how much money do you end up paying? Well, let's think about what you're paying. You're paying $900 every month, 12 months in a year for 30 years. So DKN. And that's how much will be coming out of your account, $900 per month per year you have the loan. So you're actually paying $324,000. So the question is then, how much is interest? Well, it's what you ended up paying versus what you actually took out. So interest payments come to 192,722.55. So there we go. All right, then one more problem for this unit. We have question 9. You owe $20,000 on student loans at an interest rate of 5.8 monthly. You want to pay it off in 7 years. How much does that payment need to be? So it's asking for D. So your PO, the amount you took out, is $20,000. K is 12 because it's compounded monthly, N is 7 because you want to pay it off in 7 years, and R is that 5.8%, but always put it in decimal form. Okay, so for A, we're going to solve for that D again. So it's 20,000 equals, and remember, I'm going to take the D out. And now we're going to go 1 minus 1 plus R, K, to the negative, I'm going to put parentheses here, N times K. Oh, those were my big parentheses. Divided by 0.058, divided by 12. And then we're going to get that number and divide it over. So if that went well for you, you should get that piece was 68.90438,306. I don't expect you to be that quick. Absolutely take time to make sure the calculator is working for you. Divide that in, and you get that your payment is going to be $290.26 per month to pay off that student loan. Again, take time to make sure you're getting it right on the calculator. I do not expect you to have gotten it that fast. B then says, how much interest do you pay? Well, for B, that means that we need to know how much we did pay. So what did we pay? And then we'll subtract the 20,000 from that. So we paid $290.26 for 12 months, a year, for 7 years. So we paid a total of $24,381.84. You took out a loan of $20,000. So when you subtract that, it gives you 4,300. Oops, let me write that nicer. $81.84. And that's a quick overview of payout annuities and loans. And you do have a day 18 assignment that you need to turn in. So have a very nice day.